Alrighty, welcome back. Even though you've seen this video, I made a new one. Okay. IPv6 stateless auto configuration. And this is strictly, they call it Slaac. That is strictly for IPv6. What is it? I would like to point your attention to the letters in red. Okay. Slaac requires a 64 cipher. All right. So you must use 64 cipher when you're doing your Slaac configuration, or for whatever reason, unless it's the simulator, because I am using the packet tracer. And the lab that you saw on YouTube was just the routers, and they were using a 56, and they were doing just fine. But when it comes to the IP, for the computers to get the IP, apparently you need a CIDR 64. And I proved it by using a CIDR 56 first and then a CIDR 64. But you will see that in the lab that I'm using a CIDR 64. And it is important to note that Slaac most commonly uses EUI64 format. So all we're doing, ladies and gentlemen, is the EUI64 format. All right. I have created a lab for that. All right, right here. And you know this, right? This is the packet tracer. Why am I using the packet tracer? Because I can put a little switch there and a little PC there, and I can mess around with it. Okay, I can mess around with the switches in Burl, but can't mess around with the PCs and the servers because it looks like they're all Linux-based Ubuntu or something like that. All right. Anyway, point is, all you're doing is EUI64. That's it. And so they can assign themselves IP addresses if there is no DHCP. Is there a DHCP stateless configuration? Yes, on the server side, right? But we're not doing server. We're doing Cisco routers. You can put stateless configuration on a Cisco router if you wanted to, but this is not what they're doing because I just stated to look at this right here. It is important to note that Slaac most commonly uses EUI64 format address assignment right there. And here's the RFCs to prove it. Okay. So we are using EUI64 format. This is not the first time you've seen it, but you will see it again. Yes, you will, ladies and gentlemen. So without any further ado, let's get in the lab. All right, everybody. Here we are in our stateless auto configuration lab, our Slaac Lab, which means we're using a 64-bit. Let me zoom in here. All right, so you can see the IP addresses, okay, fairly well. All right, you can see we're using a 2001, which is a global address, 4800 face, right? And then 1000, 1100, and 1200, right, for this particular LAN right here. Now, as by default in the packet tracer or any PC, it doesn't have a MAC address. Well, in this case, it has a link local address because we're talking about IPv6. But it has no IPv6 address. We're trying to give it an IPv6 address, but we have no DHCP server. We haven't configured a DHCP server on the routers as well. We have not. What all the routers have in common, and again, I'm going to show you right here in the middle of the screen. Yes, the middle of the screen. So don't scare because you can't see the lab behind you. Okay, I want you to see the CLI. All right, I'm going to do a show IP. Well, let's do a show start first so you can see what I'm talking about. If I enable, it may help. Show start. All right, so one of the first things, obviously, I kind of skipped it there. Please turn this on if you're doing, any kind of routing, which we are, because we're going across different routers, a router in between. They're not directly connected, so you must turn IPv6 unicast routing on. All right, here, IPv6 address. What I put that 1000 : but I have nothing in the interface ID. It's a CIDR 64. It must be a CIDR 64. I said it in the presentation several times. And then EUI-64. I decided to use the RIP routing protocol because since that was in the interface anyway, you can enable it in the interface, IPv6 RIP1 enable. That's it. The process number, the protocol, the process number, and then enable it. Simple as that. Okay, no biggie, no, not a big deal. So that's how all the interfaces are configured on this router, or on all routers really, with their specific IP address. Okay, enable, show start. Okay, space, and enter. Here's the EUI64 there, EUI64 there. There is no interface ID. There is no interface ID. All right, only the network prefix and its prefix length. And of course, a routing protocol that's enabled, which is RIP1, right? RIP1. Now, if we're to look, let's take a look at the IP address here, since the last router is the one we're going to be looking at. Not that we did anything special on the last router. We did not. We did the same exact thing. All right. Control Z, enable, show start, or really show IP in brief. Show IP in brief. Show IPv6 in brief, sorry. Show IPv6 in brief. You see that by using the EUI64, an interface ID has been configured, all right, using that triple FE padding in the middle, because it's taking the MAC address of that particular interface that is connected to that F01. It takes that MAC address, and you can go ahead or what it does is, because the MAC address is 48 bits, it pads it. Now, you can hard code your MAC address. Your interface will allow you to do that. You can hard code your MAC address. You can, and it'll let you, so it'll use that particular one if you wanted to. Okay? But if you do this now, it'll get rid of your configuration. But just so you can see that it's there, config T, interface F0/1. Question mark. Haha. Let me see. MAC address. There you go. Manually set the interface MAC address. You can also set your link local address if you wanted to. You can change the IP address of your link local address by putting, IP address and then putting FE80 : 1, and then at the end, if it says unrecognized command, you can put link local, and it will get rid of it. It will actually get rid of that particular address, but that's not our goal. Our goal is Slaac, and you see that by putting, and you saw IPv6 enabled here, by putting the EUI64, it did put that padding, show IP in brief. It did show IPv6 in brief. It did put that padding on there. Why is that so important? Because not only are the interfaces that are directly connected to something, all right, are getting an IP address, but your PC, by default, right, it was static. It has no IP address. Well, all you do is put it to auto config, and there you go. 1200. Is this not that particular network? So it has the 2001, right? Or in this case, the 4800 face 1200. The two is really this right here is the universal bit, letting us know it's a global address. And there's your triple FE, and there's your unique interface ID with a 64 prefix, with your local address as well. Okay, but there you go. You got to assign an IP address, all right, automatically with no DHCP server anywhere in sight, and we can ping our gateway. All right, what's our gateway address? Well, that's our router address. Can we ping our router? Well, let's find out. Let's get this right here, which is the interface. I believe, is that our interface? F01? No, it's F00, sorry. Well, we should be able to ping that address anyway, but that's not what I said we were going to do. We're going to ping this address right here. Copy. All right, because writing those addresses is painstaking. And then, oh, look how cute. I forgot I had changed that. All right, ping, and then I'm going to paste. And I have a reply. But let's see, okay, I'm connected, to my gateway. I should be able to get to it. All right, but can we get to router one? Well, let's go to router one and find out. Let's do a show, Control Z, show IPv6, int brief, right? Let's get the actual IP address of that particular one right there. Right click, copy. All right, minimize that. Go into our command prompt. It's still there, thank God. We're going to ping. I just believe things should know what we're thinking about, what we want, so we don't have to actually do it. All right, and then ping that way. Request timeout. There's our ARP. If we get more than one request timeout, we have an issue. And we do. Okay, I don't know what's going on there. Let's see if let's give one more time. Okay, so that's bad. All right, so let's see if we are able to, are we routing? Show IPv6 routes. And it shows me the 1000 that I am getting to it. So since I have already in memory, I'm going to ping paste that particular one. I have no issues getting to it whatsoever. All right, so let's do this then. Let's open up this router again. Do a show IP in brief, show IP in brief, show IPv6 in brief. All right, and we're going to ping this address. That's the other side of the router. Copy. Let's go to our PC with our command prompt. All right, and we're going to ping, paste, and let's see what happens. Well, for some reason, we're getting request time out. I don't know why. All right, but we'll troubleshoot that at another time. The good thing is that we are receiving an actual IP address from our, oh, I'm not receiving a gateway address. That's the problem. Right there. So, but we are receiving an IP address from the auto configuration, but no gateway. That is the issue right there. Okay, no biggie. That will be another lab. All right, but right now you can see that the Slaac configuration is giving us an IP address where we can actually, if I were to plug in a switch in between, and well, it is a switch in between, isn't it? If I were to bring out another PC and then connect it, and go to that PC, I should be able to receive an IP address from that particular router. Once it turns green, I guess, because it's still amber. Spanning tree. That's why we turn off spanning tree on our access ports. So let's go back to static. Let's go back to auto config. There it is right here. Okay. So we are receiving an IP address. It says our gateway here is our FE80, our like local address. And for some reason in the other one it didn't say that. Okay, no biggie. All right, so that is what your Slaac or your auto configuration does. It assigns IP addresses based on your local interfaces that you are attached to by padding it with the triple FE. That's all it is. That's all it's for. It's for assigning IP addresses that you don't have. All right? So there is your Slaac Lab. All right, that wasn't so bad, right? EUI64, very simple to do. You saw how the computer received an IP address automatically when you put that auto config. It receives the exact network prefix that it has in the router's interface. That's what EUI64 does. That is what Slaac does, because there is no DHCP server to give it an IP address. So it's very simple, okay? It's EUI64. You've seen it in the CCNA. You've seen it probably in many other courses that I have done. All right, and all the YouTube videos that I've done, okay, the EUI64. It is very simple to do, but hey, there it is. It's called Slaac. All right, see you in the next lecture.